Hello, everyone, and thank you for joining us. My name is Shir Tamari, and I lead the security research team at Wiz, the cloud security company. With me on stage is Alon Schindel. Alon leads our data and threat research team. So I would like to welcome you all to our talk about cloud vulnerabilities. Today, we would like to share with you our idea on a unique identifier for cloud vulnerabilities. We will talk about why we believe such an identifier is so important, why it's critical at this point in time, and why an open database for cloud vulnerabilities is necessary.
So the outline for today. We'll start with discussing vulnerabilities in the pre-cloud area, how vulnerabilities that are not related to cloud handled, and I believe that it will sound familiar to most of you. Then we'll move to introduce you to a new type of vulnerabilities, cloud vulnerabilities. We'll explain what is different about them and why they need a new system to handle them. We'll use 3 different examples of vulnerabilities. Each one will demonstrate different aspects of the issues that cloud vulnerabilities raise. Then we'll move to a solution proposal, and this is actually something that we worked on with the community. We have a community of people who care about these cloud security issues, and we'll introduce you our way to solve this problem. Lastly, we'll talk about what can we, as a community, do in order to help and solve the cloud vulnerability issues. So just a word about us. So we are from Wiz. Wiz is a cloud security company, and our mission, we usually say that it's to make the cloud less cloudy. We're trying to solve problems in the cloud. As part of that, we do cloud vulnerability research, and in the past year, we had some very interesting findings, and you might have heard about them. We had a session yesterday about ChaosDB, one of our findings, and the important thing is that when we investigated these issues and found the vulnerabilities, we understood that the CSPs, the cloud security, the cloud providers, they have, there is some gap in the way that they handle these vulnerabilities, and this is what we are going to talk about today. So let's start. Let's just imagine for a second that I'm a CISO. I'm on my first day in a new job, and my responsibility is to make sure that my organization is secured. So if I go for software vulnerabilities, we have some solution. So you know that I have a patch management product, and usually it checks the softwares of software that is installed in my environment, and it compares it with a database, the CVE database, that I'm sure you are familiar with. And if the version of the software that I have is listed as vulnerable, I have to patch this software, and this is how I mitigate the security issue. This is how I'm safe. But what about cloud vulnerabilities? There are some vulnerabilities in cloud services, and the CVE system doesn't cover them. So what do I have to do? So I read about blogs. So do I have to bookmark every blog that is talking about these issues? And you can see some examples here to mails or blogs about cloud issues, but none of them is centralized in one place. And if I go to my cloud security team, did you receive a mail like this, an action required from AWS? Do you remember this mail? When you got this mail, did you remediate the issue? This is a problem that we see today. And now, Shir will start walking you through the issue.
Thank you. OK, so before the cloud was introduced, companies and organizations were fully responsible for all aspects of their security, from physically protecting the data centers, for maintaining security of their network devices, and also applying security patch to any type of software. But in the cloud, things have changed. Companies no longer own physical data centers. They no longer own servers or network devices. They share those services or those devices with others in the cloud. Companies no longer maintain their own storage or database solutions. They use cloud's managed services instead. So in order to split the security, all the services the cloud provides us as users are no longer under our control. And therefore, the cloud service provider must be the one that's responsible for protecting those services. In order to split it, in a convenient and understandable way, the cloud service provider made the shared responsibility model. Now, the shared responsibility model is pretty simple. Everything that is owned and in control of the cloud vendor, it's their responsibility. The cloud vendor is responsibility for doing the physical security of the data centers, to maintain the network devices, to protect and maintain the managed services, and so on. On the other hand, we have all the responsibilities within the user side. Everything in control of the user, like software, operating system, configurations, identities, access controls, all those are in the responsibility of the user. And we, as cloud users, we need to be responsible to maintain, update, apply patches on that side. So we've been using this model for more than a decade, and it works pretty well. But we discovered that sometimes it has cracks. And in these cases, the outcome is messy and dangerous. Over the last several months, we conduct extensive cloud research, and we found critical vulnerabilities across different cloud platforms. What we learned is that some of those vulnerabilities are not simply they are in the responsibility of the cloud providers, but fixing them, mitigating them, requires the user intervention. Now, this sometimes could be a bit confusing. How come a vulnerability that it was in the cloud provider, it's a cloud provider vulnerability, how come that the user need to fix it? How does that happen? So we learned that cloud vulnerabilities are quite different than software vulnerabilities. In some cases, the vulnerable code is running on the cloud provider side, so users cannot patch it. And sometimes, providers find it hard to change the vulnerable behavior in their own code, because users are relying on this behavior, on the vulnerable behavior. And if the cloud provider will change the behavior of the service, it could actually break the user's environments. In other cases, we see that cloud vulnerabilities could also exist in cloud configurations and in default configurations provided by the cloud provider. Now, this is a real change of perception for users who mostly treat dangerous configurations as misconfigurations. And we came across cases where configurations that was provided by the cloud providers by default to users and used to be safe turned to be vulnerable. So most of the times, these vulnerabilities has no CVE or any other identifier and no severity scoring. And we discovered that most of the time, cloud users are unaware of those issues. There is no official source or database that lists them, and the outcome is many affected cloud users. There is actually a new middle zone in the middle of the shared responsibility model of new cloud issues that we didn't know exist. It has many kinds of vulnerabilities that has no standard process to handle them. These vulnerabilities does not fit in the classic shared responsibility model. There is no identification or enumeration for these issues, no severity scoring, and users find it hard to track and detect instances of those vulnerabilities in their own environments. So we would like to follow with you on 3 real-life scenarios that is based on our findings, where we found cloud vulnerabilities that was not handled properly, and users still be exposed and vulnerable to this day. The first issue is a vulnerability we found in AWS. It's a vulnerability class. It was affecting 4 different AWS services, and we introduced it in a previous Black Hat in August, Black Hat USA. So the source of the vulnerability in that case was that Amazon provided customers with a default vulnerable configuration. AWS mistakenly provided users with over-permissive resource policy, allowing other AWS tenants to perform read and write operations on vulnerable users. Now, the vulnerability made many cloud resources exposed to malicious actors and allowed those actors the ability to read and access, to actually access and manipulate customers' data. The vulnerabilities are pretty simple. Here we can see a vulnerable policy that was issued to the serverless repository users in Amazon. And as you can see on the screen, we have the policies that is responsible to integrate between the serverless repository service and the S3 bucket of the user. And the problem with that policy is that it allows any serverless repository user to access the bucket. Now, this was very surprising, and we report this to Amazon. And when we disclosed it, they took it very, very seriously. They conduct some service changes, and they add scoping conditions to the serverless repository service, and also in the documentation. They replace the old policy with a patched one. And now, when users come to use the service and they read the documentation, it's guiding them to add the scoping conditions. And if they copy the default policy, it's already patched. Additionally, they also emailed vulnerable customers about the issue. And this is the email I received in my private AWS account that tells me that there is an action required and I need to update the bucket policies for my AWS serverless application repository. So Amazon did a lot of things in order to remediate this vulnerability. But in a survey we conducted, we found out that 90% of cloud users are still vulnerable, even though we reported this vulnerability almost a year ago. So how come so many customers are still vulnerable to this vulnerability? So surprisingly, AWS cannot update and mitigate the current policies of users. AWS cannot edit and apply the scoping conditions themselves on users' configuration, because changing the user configuration could break the environment. It's actually changing the behavior of the resource. And if the user is relying on this functionality, it will break their environment. So users must apply the scoping conditions themselves on their own responsibility. So AWS emailed vulnerable customers, right? They sent them emails, they alerted them, please update your policies. Could it be possible that users just didn't treat that email or ignored it?
Wait, has anyone heard about this issue before? Or do you have an AWS account that? Okay, no. So I don't know if it means that no one heard of it or no one received the mail. But
yeah. So let's see. Let's start by asking ourselves, who is receiving these emails? Is it the IT manager of the company? Or is it someone in the R&D division? We saw cases where it was developers who were receiving those emails. What would they do with them? I mean, at best, they will send it to someone in security, but at worst, those emails will be forgotten. Another issue is tracking. Let's say the email does find the right person in the organization. How would they track the remediation process? How would they prioritize it? Security teams have so many alerts, vulnerabilities, and incidents to handle, so how should they prioritize this kind of email? Is it critical? Should we stop everything and mitigate it now? Maybe we can postpone it. I mean, there is no severity scoring, so you have no idea. And another issue is tracking. I mean, how can we track these issues? How can we know if it's already been addressed in the organization? How could we know if someone already patched the policies and scoped them with the proper conditions? So the thing is that users simply lack this information. They don't know. And this is because the whole process of mitigating cloud vulnerabilities not really exists. So let's summarize this example. We learned that cloud vulnerabilities could exist in cloud configurations. And remediating it requires user intervention. These type of vulnerabilities cannot be mitigated by the cloud provider itself, and it requires the user to take an action. Users have no process or methodology to identify, prioritize, and track these vulnerabilities. This is a new kind of vulnerabilities. Usually we used to that we know about the vulnerability, we know about the software that is vulnerable for a specific version, and we know that it's our responsibility to monitor that and go to fix it. But when it comes to cloud vulnerabilities, the process does not exist. I mean, people just don't know that the cloud could be vulnerable. And the result is that most users are still vulnerable. OK, let's continue with the next example.
Mm-hmm. Thank you. Okay, so the first example was about the configuration. Now, the second example is about cloud middleware. So first, what is cloud middleware? So cloud middleware is a collection of software that is used to integrate between customer VMs to cloud-managed services. And what does it mean? Sometimes when you deploy some of the cloud services, in order to manage your VMs, they need to install some kind of an agent. And this agent, in many cases, is installed silently. You don't know about it. So one case is the OMI. OMI is a very popular agent used by Azure on Linux VMs when they want to manage Linux VM. And we know that it's like 60% of Azure customers have this agent. So we found 4 vulnerabilities in OMI. We dubbed them OMIGOD because of we thought it would be funny. And the worst of them enable a remote attacker to execute code with the highest privileges on a VM, root privileges. And it put thousands of customers at risk, because I told you this agent is really, really popular. Now, Microsoft, let's see how they handle it. So they published it, they issued 4 different CVEs, so it's something, okay, we know CVEs, on September 21 as part of Patch Tuesday. One of them was an RCE, as I told you, 3 LPEs, with even they had a severity, and they asked the customers to update their OMI agents. But, as I told before, customers didn't even know that this agent exists in their environment. And I mean, it's something really weird to us. I mean, oh, please update it, but you don't know that it's there. And there is this tweet by Kevin, it went viral, and I think that he summarized it well. So Microsoft doesn't have an auto-update mechanism, so now you need to manually upgrade the agents you didn't know existed, as you didn't know, as you didn't install them. Now, this is not even the end. So we believe that the real turning point is that 8 different Azure services were impacted by this vulnerability. And some of them are really popular, like Log Analytics, Azure Automation, Azure Sentinel, and more. And usually, when we work with CVE, we correlate it with CPE, the Common Platform Enumeration. And this is how you know, using the CPE, you know which products are affected by the CVE. Now, in this case, the CPE must have been the vulnerable Azure services. It is really, I mean, it is really unprecedented to add to a CVE the services that are affected by it, but we believe that it must have been done in this case. Now, today, actually, when you go to the CVE page on MSRC's portal, you can see the names of the services. But initially, when they published it, it wasn't there. So if I summarize the problem is that Microsoft had a CVE, but customers didn't have any way to know if they are vulnerable, if this issue is relevant to them, and which Azure services are affected by this by this vulnerability. And eventually, as I said, Microsoft responded. It took them like 2 or 3 days after Patch Tuesday, and they had this guidance that they published, and they decided to deploy auto-update for these agents. I mean, we have to say, like, they responded well, but it took them 3 days. But this response came after this vulnerability has been exploited in the wild. Malicious actors understood the issue, understood that most customers are vulnerable, and there's an exploit that they can use, and they started exploiting it, and customers were at risk. So let's summarize. First, so we learned from this example that vulnerabilities can be found in pre-installed middleware. So Shir showed us before that we have the CSP side, what is in the CSP ownership, and we have the user side. But there are you see something in the middle that is the software that the CSP installs on the user machine, on the machine that the user manages. So it's quite like a new situation, and we need a system, we need a way to handle it. So first, we believe that we need identification. It's not only a software vulnerability. If Azure services are affected, we need a way to identify it. We need a way to have a unique identification, and we can't just treat it as like the issue with the OMI that affects some services. It's really difficult to discuss it this way. Then we need better transparency. We need Microsoft to tell us when you have this vulnerability, all these services are affected. And then there should be an easy tracking system. If you went to your Azure portal, it was really difficult for you to know that you are affected, that you have now machines that are vulnerable. And we believe that it should be easier to track and understand whether you have this issue. Lastly, remediation. So in this case, Microsoft asked customers to remediate it themselves and change the way their guidance a few days later. And we believe that for the cloud middleware, we should have a very like a clear process, and it doesn't have to be a process that we think about only after the vulnerability was released. It should be a process that you know of, because we know that the cloud middleware is there.
For the third example, let's talk a bit about ChaosDB. ChaosDB was an unprecedented vulnerability, cross-account vulnerability, in Azure Cosmos DB. And just yesterday, Nir and Sagi from our team presented it here in Black Hat. So Cosmos DB is a very popular managed service that is used among a lot of Azure customers. And the ChaosDB incident, the vulnerability, was that customers' access keys were accessible and made it possible for malicious actors to perform read and write operations on their databases. So when we disclosed this issue to Microsoft, they handled it very fast, in a record speed. And they removed the vulnerable feature within 48 hours. But customers' access tokens has been exposed and had to be revoked and regenerated. So the thing is that Microsoft cannot regenerate the keys of their own customers. Because if I'm a customer and I'm using this key in my production environment, if Azure will revoke it, it will break my environment. So this is why users were required to take an action and regenerate their own keys. So to inform the affected users, Microsoft emailed them and urged them to regenerate their keys. The thing here is that people receive this email that requires them, it says action required, and actually it's not the email, this is the PSA. So they received an email that says action required, you must regenerate your keys. But the email was lacking a lot of information. Microsoft at the beginning didn't want to publish anything beside the email, like this blog post, and they didn't disclose the time frame where customers were vulnerable and potentially exposed. So the remediation process was a bit unclear. People really didn't know if they were compromised, if their keys were compromised. Many users that did not receive the email were very confused. They tried to figure out if they had the vulnerable feature enabled. In this case, it was the Jupyter Notebook. It was very hard, even impossible to detect. So Microsoft saw the gap, and they decided to publish a blog about it, but it was still lacking a lot of information. And in addition, as we mentioned in the previous examples, this issue, just like the others, it didn't have any official identifier or detection rules, which make it very hard for users to remediate and track the process. How do I know if the keys in my organization has already been regenerated? If I'm a new CISO that comes to the organization, I don't know. I don't have a track of that when the keys was regenerated. So all those questions could not answer easily. So if we summarize this example, we learned that leaked access keys could not be handled by the CSP alone and requires a user intervention. There is no detection rules or guidance for customers, which is making it very hard to treat and track those issues, is there is no standard of how to handle this kind of issues. And again, users need much more information and much more transparency for cloud providers. So to summarize the three examples, the first thing we learn is that there is no standard notification channel. Cloud providers use emails and internal dashboards to notify customers, but it's barely enough. They use the same channels to notify a lot of things, not just security things. And it's very confusing because who is receiving these emails in the organization? If they send non-security stuff, so I want my IT to receive it. If it's security stuff, I want to receive it. Moreover, security people often find themselves confused and lack the ability to track and remediate because they don't have a process to handle those emails. Another big issue is the lack of standard severity scoring. Because those emails usually contain like critical or action required, it's not enough for us to prioritize those emails, and we don't know where and when we should treat them. And again, we come back to transparency. We believe that some of those vulnerabilities we never heard of, because usually we get the emails, the action required emails, only if the CSP suspects that our environment is vulnerable right now. But what happens if my environment will become vulnerable in 2 months? If by accident I will apply a vulnerable configuration, I will not receive this email again. There is no continuous process to track if those vulnerabilities affecting me. And the transparency issue is that we don't have a database that lists all the issues. We as cloud customers, we would like to know about all the vulnerabilities, not just the ones that affect us today and right now. And all the vulnerabilities we show you, we know all the details about them because we are the one who found them and we disclose them with the vendor and we pressure the vendor and we got a lot of details from them. But we believe that other researchers in the world also report cloud vulnerabilities and we just don't know anything about them.
Okay, so now we'd like to move in. These are the 5 points. So Shir explained them brilliantly now. First, what you need to remember, this is what we want you to take from this part, that first, vulnerabilities are not only in code and software. Vulnerabilities can be in configuration, related to keys, and on many other issues. So this is one thing we have to remember. And this is why the current system, the CVE system, doesn't cover other vulnerabilities. Then, there are five things that we want you to remember what we think that we lack today. The identification, tracking system, transparency, severity standardization, and remediation steps. Now, on top of that, when this, previously, like the last slide, we discussed what we need for every vulnerability, but we also need one place where all the vulnerabilities will be stored, and all the information about them will be stored, a centralized database, and it must be public for anyone to use, for cloud users who want to track their own environment, and for security vendors who want to integrate it with their solutions. This database can only be fed from the cloud providers themselves. And we believe that it is a shared interest of the cloud providers and the cloud users. I mean, this is the way. If we have this collaboration and we have all this information public, we will all be more secured. And to give you a taste of how it should look, let's go over the third example, the ChaosDB example. And let's see let's imagine together how it will look like. So first of all, we have an ID. So we chose just a random identifier for it. And again, it's difficult when Microsoft wrote about this issue. So it was regarding the issue on Cosmos DB. But you know what happens when there's another one? If there's another issue on Cosmos DB, how do you know which one to treat? It's really difficult to reference them this way. So first, we give it an identifier. Then, as Shir also explained, we need to have a system to decide and determine what is the severity of the issue. Because today we get a mail with action required, a severe issue, or just a configuration issue. We must have some kind of a system. And for the CVE, for vulnerabilities, we have the CVSS system, which is kind of an agreed way to rank different vulnerabilities. And now if we have one vulnerability in Cosmos DB and one in AWS, I have to know how to prioritize which one is more important to handle. And this system should be universal for all CSPs. Transparency. So here for transparency, we have a few different points. So one, we have to know which product is affected. So for ChaosDB, it's the Azure Cosmos DB. It's quite easy. But if you remember, for OMI, the example that I showed, it was more difficult, and you had different services, and Microsoft didn't even publish it at the first place. Then, since for cloud services, there is no version. When you use a cloud service, you don't know what is the version because the code is running on the CSP side. So you have to let a customer know, to give them the tools to know when he was affected or if he was affected. And for that, we suggest using the time affected. I mean, writing a time when if you use the service then, it means that you are affected. Lastly, the risk. What is the risk? I mean, you are vulnerable. What could have happened to your data? It has to be really clear and really understood. And for ChaosDB, for example, at the first place, Microsoft didn't even want to publish anything about it. And we believe that the transparency and that customers will be able to understand the risk and choose themselves. I mean, it's not only up to the CSP. Customers should have the power to understand whether whether the information was compromised or whether they have to take some actions in order to remediate it. It's not only the CSPs that should decide about that. And remediation. We showed you, each of the examples we showed you required different remediation actions. And with software, it was quite easy. You have a CVE, and you check if the vulnerable version is in your organization. If you have it, you patch it, and then you are safe. Unless it's exchanged, and then you are not. Yeah, so you must have really clear remediation steps to help customers understand how to remediate the issue, because there's no standard in that. And there's another item that we thought that could be, if we're trying to do things better, maybe we should have it as well. A way to detect it. So again, for cloud services, it's quite difficult to find. I mean, if you are vulnerable or not, because it can be configuration, it can be if you regenerated keys. So we propose to add a Reg Rule. Rego is a CSPM language. I don't know if you know, but it's some kind of a script language. You can run it in your cloud. It makes some checks and can tell you if your configuration is okay or not. So we propose, if we're trying to do things right now, let's also ask for rules. I mean, how can I detect whether my environment is vulnerable or not? And here you see this is some kind of an example for the table. This is how the database would look like. We will have different issues, and this one is only a mock-up. It's not real. But you'll have all these issues. This information will be public, and everyone who wants to evaluate their security posture will be able to use it. And also, some other security vendors will be able to integrate it with their products in order to help customers secure themselves. And there's actually a funny story about that. So I don't know, how many of you here are really practitioners who have to keep organizations safe. But we showed it to someone that it is a real job, and he asked me how can I get it? Like where does this database is located? And we told him that we did it only to demonstrate. But I think for us it really showed that there is a need for this database. So let's get back. If you remember, at the beginning of the talk, I was a CISO on his first day of the job, and I told you that if for cloud vulnerabilities, I don't have any way to check whether I'm vulnerable or not. I don't even have a way to find what is the latest cloud vulnerability. How do you do it? So if I have now this database and I have all this information, I believe that it will make our work much, much more easier. And I'll be able to ensure that my organization is secured more easily. Okay, so what's next? So that was, we tried to explain and convince you that there is a problem. We proposed the solution, but how do we, we don't want to just talk about the solution. How do we make CSPs make these changes?
So first, we would like to ask you to join to our community. We have a Slack community with a group of people that really care about this issue and would like to promote the initiative of a cloud vulnerability database open for all. We have more than 130 members from all over the world and from all over the industry, from finance companies, security, data, Fortune 500, and all of us are sitting together in the Slack group how to promote it, how to push it, and put some pressure on cloud providers and make it happen. so that all of us could enjoy this database. So I would like all of you to think about joining us and join us with the initiative.
Yeah, and actually, a lot of the ideas that we shared with you today and the way we understood the problem and our proposal is based on discussions and meetings that we have in this group. So this is like there are people out there who care about it and believe that the problem, that it's a real problem, and they are ready to take action. And speaking of that, we have other projects. I mean, we are not the only ones who work on that. And there's also the CSNF project, and there's CSA, the Cloud Security Alliance. They have projects for unified cloud identifiers. MITRE, the organization that works on like the original CVEs. They are now trying. We're actually working with them on how CVE can be applied to the cloud. But the bottom line here is that there are many different projects, and none of them has succeeded in changing reality. And we believe, I mean, it's okay, we're trying to collaborate, we're actually working with all of them, but it takes time. And we believe that it's not only up to some people who think about it, it's about how the industry reacts. And we really want you that the next time that you receive an email from AWS about an issue or an email from Azure about a cloud issue, how about to reply and tell them, okay, I don't say why there is no identification to this issue. How can I track it? How can I make sure that in 6 months this issue doesn't repeat in my organization? Ask for more details. And we believe that all these questions can make them understand that we care about our security and we want to know this information. Yeah, so yeah, okay. So the bottom line is that the power is in your hand, and we believe that the real way, I mean, we have this proposal, we are going to promote it, and we really believe that we should have more power against the CSPs, and we should be clear that we want more security, and we deserve more security. And this is the way. The path is to make them, when you sign the next deal with AWS, how about bringing up these issues and asking them? And if we'll keep asking them these issues, we believe that eventually they will start reacting, and we will be able to be more secure.
Yeah, during our disclosure, when we disclosed vulnerability to AWS, a lot of time when we see that they don't publish enough details, or when they don't tell how to track it or give remediation guidance, we put pressure on them because we know how important it is for the community and also for our customers. So we see that pressure actually works. So we really want you guys to put some pressure on the cloud providers, and this is the only way to make it happen. Well, thank you very much. So we would like to welcome all of you. If you want to read about to see again the presentation, so we have it as a blog post on our website. We also have the Slack group we mentioned earlier, and we would love all of you to join. And you can also approach us on Twitter and ask us questions if you like. And also questions now, I believe. Yeah.
And thank you. So really thank you for attending, and we would really love to engage and hear your comments. And I mean, you can now just not ask questions, that if you have a comment, it's also okay. And we'd also like to thank Black Hat for hosting us, and it's been a pleasure for us to present here. So now, questions and comments. Yeah.
Yes, I'll take them.
Sure.
So, thanks. I like the initiative, hence the comment. I would like to comment on the first issue. That was the AWS, correct?
Yes.
Yeah. So, of course, the cloud vendors need to take some responsibility. I think that was a good example of a very irresponsible email, because it did not mention, I'm not, if you can show it again, but it did not mention the word vulnerability. Right? It was worded to me like a marketing email. Hey, dear user, we have now added features
Yeah, it does mention the action required, but let's see.
Yes, it does mention action required, yes, but what action? Why would I take action? Should I act on a new feature that they now have released that I could potentially take into use and have fun with? It does not tell me that there may be a potential business impact to data I'm using. So this is worded in a way that they're trying to wash their hands of this issue. So I think your 130 plus working group, I will join that and comment more there. But do any of the cloud vendors, the providers, participate in this? Because if they don't change their wordings in their emails, I think it's an indicator of they are not interested in providing this information that would be crucial for us to actually understand if it's a nice feature that we could now act on or if it's a vulnerability with a business impact.
Yes. Right. First, thank you. I would say that we do have some people from the cloud providers in our group, but they're not representing the cloud providers. Some of them are just personally taking the initiative. And regarding this email, Amazon did a lot of changes. It's not just these emails, they also had configurations. But I agree that the wording here is very soft.
Yeah. And what's your name? No, what's your name? Undisclosed. Okay. So you can tell me personally later, because we expect to see you in the community. But yeah, we are also working directly. For example, we are meeting MSRC today. I mean, we also have other passes because we know that it might be difficult for them to be part of this community. So we are also working directly with them, and we see that they respond and they also care. It's something difficult for them, but they also care.
So I think it's a great idea to have a place where you have the missing information that you have mentioned. I question, though, the idea of having yet another new identifier as opposed to simply enrich CVE, because, I mean, it's quite funny for me. It's kind of back to the future, because 30 years ago I was involved in the discussion to create CVE. So CVE is just a key, right? It's just a number. The goal was from the beginning so that it's the simplest it can be with zero information, just an identifier, so that as many others can actually use that as a foreign key, as a united pointer.
Yes.
And now if you try to come up with yet another identifier, then it gets things confused. You gave this example of AMI, which has a CVE number. So then what? We would have one in your system and another one in the, you see?
Yes.
So I think it's
yeah,
it's a bit confusing if you want to have your unique identifier.
So we don't claim that, we don't really, it's not that we need a new identifier. The thing is that CV is not just an identifier. It's also a format, a standard, and it has certain fields and certain integrations. Yeah. And not always it works, it fits for cloud vulnerabilities. But the thing is that we don't claim to have the solution. No, it's just like a community discussion, and extending the CV is one of the good ideas that people consider in the community.
Yeah, we are actually going to present it. I'll just say, so we don't. I mean, we suggested an identifier which is not CV, because we know that some people in our community that really don't believe that this is the path to the solution. And I have to say that, I mean, eventually what we first need is an identifier, and I really agree that it might be confusing. I mean, we don't say we must have a different identifier, and we are also going to present this meeting to MITRE, to the guys who work on CVE, as part of their extension discussions of CVE to the cloud. So we know it takes them time. There are more it takes them more time to react and change, and we believe that we need a faster solution. So we don't know exactly how is it going to look like, and I really agree that it will be confusing to have another identifier. But so we're more generally speaking, that there is a need for identifier. We don't it doesn't necessarily have to be a new one.
Yeah, I mean, I'm not in favor of extending. I think CVE is already, it should have remained what it was supposed to be, just an identifier with a clear description. And then have as many as we want, other databases that point to that and complement with the detection, with the severity, with whatever. And I think what you do separately for cloud is great. But because if you keep enriching CVE, what's going to happen is you will have the same thing that was happened with IDMF for intrusion detection at the IETF, which is like this huge standard that took 3 years to just reach some consensus, and that nobody uses at the end, which is kind of stupid.
Yeah.
Well,
thank you. And I hope you also join the community.
First of all, thank you. It was brilliant. I'll also join your group. Going back to your proposal, I was curious, you mentioned 5 different items or categories. What led you to select these 5 in particular?
You're referring to the notification and severity?
Yeah. So I think this is what we came up from the discussions we had. So in our group, we took some examples and additional examples, not these only 3, and try to see which different categories do we need to have there. And again, we are not saying that these are the only 5, or it must be only these 5, or maybe there's one that doesn't even to even be there. But I mean, this is how we saw that we can analyze the issues and provide the best information for them. And of course, if you have you're thinking else and you have a different opinion, we'd like to hear that and to change it. And I assume that since cloud issues vary and there are like very different issues, so we will probably need. I mean, some of them won't have time affected, and some of them will, and maybe they will need more details for a specific new type of issue that we've never faced before. So it has to be like an agile walk, and that we'll learn from.
Thanks.
Thank you. Any other questions?